Hi, welcome back to the lesson 3. So we started pointers in C++ as our lesson 3. So today we are going to look at the pointers in array. Okay, so up until now we have just looked at the pointers and its basic concepts and learned about static and dynamic memory allocation as well as runtime and compile time. So those concepts are going to be really useful for today's lecture as well. So let's start. So we already know that what is a pointer. A pointer is such kind of variable that can only hold the address of another variable. So it cannot hold the data itself. So it can only be pointed to the data via address location. So whenever we store something in our memory, whether it is static or dynamic, the memory allocates some space to it. Okay, so that space has a unique kind of address and which can be stored in pointer and through which we can access data as well. So this is what happens in the array as well. So in array, every element takes some place. So it is the combination of multiple variables of same kind of data. For example, if I say integer data type array, so it will hold the data types only based on integer with multiple elements. So it can be any number of elements. And the main point about arrays is they are stored in contiguous order. So due to which the address at which they are stored are differ by the byte size. Okay, so when we talk about integer data type, they usually hold the 4 bytes of space, and when we talk about character data type, they hold about 1 byte of space. So in address they are differ by these number of bytes as well. Let's demonstrate how it works. Here is an example that demonstrate an array where there are 5 elements and each element is considered as data 1, data 2, data 3, 4, 5 respectively, where each element has its unique index position, that is 0, 1, 2, 3, 4 respectively. Now as you can see, I have got some kind of random address. So addresses are usually in hexadecimal. Now hexa 00 and the second is hexa 04. This is due to the fact that integer data type holds 4 bytes of space in memory. So you can see that first position it is 00 and second position it is 04 and third is 08 and so on. So every element is differ by 4 bytes in memory allocation. Now let's discuss the general syntax for pointers to array. So first of all, you have to declare a pointer variable. So in this case it is star ptr, and next thing is you have to declare or initialize an array so by any name, and you can see here. So let's demonstrate this concept in our compiler. Let's go. Here we are in our compiler, so let's start our program. Include the header file here. Now first thing first is that you want to declare a pointer, or maybe you can later on declare the pointer. So we can say that integer array of any size is equals to 1, 2, 3, 4, 5. So what will happen is we have already learned in our array concept that the compiler will automatically knows the size of a array. So we do not have to write it in here. But whenever you are not initializing, then it is must to mention the size here. Now let's have a pointer. We already discussed in our basics that what kind of pointer must be used. So we will use an integer pointer due to the reason that we are dealing with a integer data type. Now we point it towards null, so in memory it should not point towards any kind of raw location. Now we have a pointer which is pointing towards null. Now let's point it towards the array. Now as you remember that we used to say that and some kind of variable, okay, we were used to do this. Now here variable is our array, so what we can do is we can say that array first element. Now the pointer is pointing towards the first element of array. Let me show you how. So here you can see that this is the first element. Now the pointer is pointing where? This is the place where it has been pointed, data 1, because index is 0 and where what we use there as an index, sorry, not I, we will use 0. Now it's correct. Now you can see index 0 and the array pointer has been pointing to index 0. Now let's print the address. C out ptr. What should it print? It should print the address of first location. We have some error. Oh, I'm sorry, I've saved this file as a .c file and it should be .c++. Okay, so let me just rename it. Okay, now let's start. Now as you can see, there is some kind of address, some hexadecimal number, and it is showing the address. Now let's demonstrate what will be the address of next location. We will say that there is another pointer, integer p star ptr2, okay, which is pointing towards null. Okay, now let's say that ptr2 is pointing towards the address of location 2. Okay, now let's print the ptr2. Okay, and as I have already discussed that these will be differ by 4 bytes, so it will be clear here as well. Now as you can see, some hexadecimal number and they both are differ from 4 bytes. So it's nice that we have learned about this and you can understand the concept of difference between the elements address. Okay, so now you got the ideas that how they are differ in 4 bytes. Practically you have seen it. Now you may ask a question. It will be really difficult to use separate pointers for separate variables. For example, if I have the data as 100 elements, let's say I have 100 elements here, 100 element. So by this method, I will do what I will declare 100 pointers, which is not obviously not a good way to do. And programming is all about efficiency and solving the problem in a best way possible. Okay, so what is the best way? We will use the concept of increment and decrement. Let me demonstrate that for you by diagram and then we will implement those concepts here in compiler. Let's get back to the presentation. Okay, so I welcome you here in the presentation. Here, increment or decrement concept can be demonstrated. We can see that one pointer can be pointed towards the multiple elements by the concept of increment and decrement. Okay, so PTR is the initial position that we have pointed towards. Then PTR plus 1 is the second position, PTR plus 2 is third position, and so on. So you can say that we can use and utilize the concept of increment for accessing the values in the forward direction, or for backward direction we may use the decrement operators. Now there is another concept that can be shown here as well. which is array of 0 is same as only ARR. Let me show you in the compiler what does it mean. Okay. Now here I will just remove this pointer because we don't need this anymore. And I will just remove this. Okay. Now one way to initialize the first address location to the pointer is this method that we already demonstrated, which is the AND array at index 0. Now let's see the another method, which is ptr. Just only write the array name. Okay. And let's see. So it is also pointing towards the first element address as well. So this shows that ptr and array at 0 is equals to ptr array. Okay. So we will use this syntax for further demonstrations. Now let's print out the address of each element and also access each element, so you get the idea that how you can access the elements in an array as well. So let's start. So first of all, we will just write the name of array, and this gives the pointer the first location address. Now we have the first location address, so what we can do is that integer I is equals to 0, I is less than. Okay, now let me test you guys. What we can do? Do we know the size of an array? We cannot use that null operator as the case of character array. What we will do is we have learned about how to find the size of an array if we don't know. That is size of array divided by size of int. So for now I will just comment this just to test out will it work or not. Let's just confirm it first, that size of array divided by size of int. Okay, let's see what we get. So it is 5 and we have a 5 size array. So that is working good. Okay. So let's get back to our for loop. Now the I will be incremented by 1. Now as you already know that accessing elements via pointer, we use the concept of dereferencing. Okay. So what we can do here is see out. What we can do here is star what? PTR. Okay. Plus I. And we will print it in different lines. Let's see what we get as a result. Alright, so we got the 1, 2, 3, 4, 5. So we have successfully accessed the elements in an array. So how does this logic work? This logic works like this. First of all, we use dereferencing, that first of all we have assigned a reference of this array first element to the pointer. So this pointer has the address of this first element. Now to dereference it or access the element, we use pointer, this steric sign once again over the top of pointer. Now I do not want to have this element again and again and again. I want to increment the pointer by one position, so I should be able to access all elements. Now let me give you that diagram once again. As you can see, that pointer is pointing towards the first position. Now I have to move about one more position so that I should be able to access another location as well, and plus 2, plus 3, plus 4. Okay, so now the confusion may arise. The arrays, every element is difference by 4 bytes. But why do we use plus I? because the plus y difference is only 1, because I is equals to 0, then I is equals to 1, then I is equals to 2, and up to so on. So the increment is only 1, and we are accessing the elements by byte difference of 4. The reason behind it that we discussed in our introductory video when we were discussing about the memory management while talking about the bytes, that every integer element has 4 bytes, takes 4 bytes of data. Now that is not represented by whole addresses. Every single element is represented by only the first address of byte. Okay, so in this case, let me just print the addresses and you will see the difference between them. Now as you can see, this is 4, this is 0, 4, 8, C, 0. Now these demonstrate that there is a difference of 4 bytes in them. You can convert this hexadecimal into simple numbers by an online calculator, so you will get the idea what this actually means. Okay. Okay, now we have what? 0, 4, 8. These are the difference of 4. But to access them, you will just increment by 1, because each element is located at different memory addresses, and every one is separated by 4 bytes of space between them. Okay, so that 4 byte space is due to the fact that we are using integer data type. So we will just use +1, +2, +3. So if it was character, it will be only 1 byte of data. So this is nothing to do with the byte size. This is all about accessing the elements via address. Now you have got the idea, so that how it is located within the memory. We have printed the addresses and looked at it that every element was at a difference of 4 bytes, as well as we have seen that how we can access all of these elements. Let's just perform a simple calculation so that you may know you can perform different tasks with it. So let's say sum is equals to 0, and we will say that integer sum. Okay. So instead of printing all this, what we can do is sum plus equals to sum. Okay, let me tell you one more concept. Sum is equal to sum plus star ptr plus I. Okay, so this is already we have discussed that what does this mean. Now we will use another bracket and we will print out this sum. Let's see what we get as a result. We get 15 because 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, and 10 plus 5 is equals to 15. Now, why I write always like this? Plus equals to. Now, this syntax and the previously typed syntax was equal. So, just for simplicity, we always, you will see many coders like write like this. Okay, so these are both same. So these are also, this is also equals to, I'll just comment it here, sum is equals to sum plus star ptr plus I. Okay, so this was the concept of pointers and array. There is more explanation to it in the next part of video. So first of all, you understand this concept, then later on you may watch the other video as well. So I'll talk to you in the next part of this lesson. So see you there.